Okay, so this is the 2023 Higher Level Maths Leaving Cert Paper 2, question 6. So we have, let's see, part A here. We have state whether the following statement is true or false. Two angles are vertically opposite if and only if they are equal in size. Now I'm saying here that this is false because we know that vertically opposite angles are equal. However, equal angles are not always necessarily opposite, and I've given an example here. You have 30 degrees here and you've got 30 degrees here. They're equal, but they're not opposite angles. So that's my answer there and my reason. Okay, let's have a look at part B. Two diagrams below show the same rectangle ACEG. Not to scale, the points B, D, and E, so B, D, and F rather, lie on AC, CE, and GE, respectively as shown. AB is 20, BC is 30, and AG is 90. Let's see, GFA, so I'm presuming they're talking about these thetas here, so this angle is equal to this angle is equal to this angle here. In diagram below, GE and BD are extended, so GE is extended out as far as H, and BD is extended up here as far as H as well. Let's see what we have to do here. Prove that FE is equal to EH. Prove that this distance here, FE, is equal to EH. Use congruent triangles. Give a reason for each statement that you make in your proof. Okay, so let's run through that. So first thing I'm going to say here is I'm going to have a look at two alternate angles, theta. So we know that this angle down here, this angle here is theta. So that means this angle up here must be theta as well, because they are alternate. This here is parallel to this line here, because it's a rectangle. So this angle and this angle here are both alternate. So that's the first thing I'm going to say. So I'm going to say here we have a statement and a reason. So the statement is that angle DBC, the size of the angle DBC, so that's DBC, this angle down here, is equal to the size of the angle EHD. And the reason is they're alternate. Alternate angles. So those two are equal anyway. The next thing I'm going to say is the size of the angle HED. So HED, this angle here, is equal to the size of the angle FED. Why? Well, they're both equal to 90 degrees. And why is that? Well, given that it's a rectangle. Okay, so we have these two angles here. These two are right angles here. So we know also, by the way, that this angle here is theta. So if that's theta, then the third angle here in both triangles must be equal as well. So we've shown that the two triangles are similar anyway. So I'll just state that then. So we're going to say that angles FDE must be equal to angle HDE. And we could just say something like angles in a triangle. Okay, so we've shown that also this angle here is equal to this angle here. Now we've shown they're similar but not necessarily congruent. So to show that they're congruent, what I'm going to do is say that ED is equal to ED. So the distance ED is equal to the distance ED. There, it's a common side. Now we can say, therefore, triangle FED is congruent to triangle EDH. So these two triangles are congruent. Therefore, what were we asked? Prove that FE is equal to EH. Therefore, the distance FE is equal to the distance EH. And that's it. use congruent triangles, which is what we've done. Now I'm saying these two are congruent. Why? Because of angle, side, angle. This angle here, this side here, and this angle here. Remember that the side has to be between the two angles. So it would be angle, side, angle. Now I suspect there are a number of different ways of doing this. This is just the first way that came into my head, so that's what I did here. Hence or otherwise, find the size of the angle theta, give your answer correct to the nearest degree. Okay, so let's have a look at our diagram again. Now we can say here, we know that this angle here, by the way, is theta as well, this angle here. So I can write in a theta here. Now we can say there that if this is theta and this is theta, this is a transversal, these two here are corresponding, therefore these two lines here are parallel. So if they're parallel, we know that this is 20 centimeters here. So therefore this distance from F to H, so I can say that F, the distance from F to H is equal to 20 centimeters. Now if F to H is 20 centimeters, then F to E must be equal to 10 centimeters. So this must be 10 centimeters here. So that's 10 centimeters. If that's 10 centimeters, we know that if this is 30 centimeters here, it's 50 centimeters in total across here. So that means this must be 40 centimeters here. We know that this is 90 centimeters along here from G to A. So we have this triangle here. So this triangle here has the angle theta that we are required to find, and we have an opposite and an adjacent, so we can use tan of theta is 90 over 40. So that's what I'm going to do. Let's write that out. So tan of theta is equal to 90 over 40. That gives me theta is equal to tan inverse 9 over 4. And when you do that, it says to the nearest degree here. So let's see, when you do that, you get 66 degrees. I think that's all we had to do. Hence or otherwise, so we did the hence bit, I guess. Find the size of the angle theta, give your answer to the nearest degree. So that's it. And that's it for this question.